Hello there, I'm St-Pierre and you're listening to Go Podcast. I wanted to talk today a little bit about WebAssembly runner and how could they be used and, could they be useful in your application and whatnot. So before we go there, I wanted to let you know that I don't know if you knew, but Go 1.21 is about to be released, and there's two small function that will be added to the built-in function. So the min and the max function, which will allow to, well, as you might guess, get the min value or max value from a variadic series of the values that are passed, which are type as any. So if you are to pass some int to that to those functions, well, you will get the min and the max, for example. So useful for when you have some slice of int, for example, or a slice of string and things like that. If you have a slice of struct, though, well, it's not really that. It will not really be helpful for that. There's no way to pass a delegate, for example, like in the sort function, for example, to get the min or max value from a struct. It's not really for that, but just to prevent some for loops when you have simple slice. All right. So what about WebAssembly runner? Well, I was working on the static backend lately, which is my open source backend API, and there has been something that I've seen in all those years that are recurring to most of the business / enterprise line of business application that I've built or been part of, and it's something like plugins. So having having your system doing some things, basically, some functionalities from a basic point of view. Let's pick a real example, for example. So as I've mentioned, I've been mostly working with data all my life. So things like pipelines and whatnot. So and when you work on those types of application, let's say you need to process incoming files that are coming from all sorts of sources, external sources from your company and whatnot, and you need to process some data from there, a basic ETL, extract, transform, load to somewhere else. So you have, for example, I don't know, Fixlent files, Excel files, tab files, CSV files, a couple of things, even PDF. I've seen PDF, but a couple of things like that might be entering your way, and your system or your this specific pipeline needs to process the data. So what I've seen often is that, well, one way to approach that is to try to build a basic pipeline that would work with most of the files that you are going to receive, but at some point you will need to work around some exception and whatnot. And what I've seen so far that was working very well was to have some kind of a plugin system, some kind of a way to add functionalities to this sorts of pipeline processing of data without having to recompile the application or redeploy and whatnot. So just having a way to come in quickly, say, you know what, I will need to I will need to build or add a specific functionalities. I've seen things built in Lua for those kind of things. One another example was having some way to load classes dynamically. So in my previous life as a programmer, I was doing some .NET, and there's a way on .NET to load dynamic classes at runtime and whatnot. But so that is something that I always find was missing from Go. There's a plugin, a plugin system ish in Go, but it's not working. It's not really that. It's not really something that you can plug an external file on a running application and it's able to do something with that. So that so there, I was playing around with the idea of maybe trying to have WebAssembly doing that that kind of job, or this type of responsibility of action to be done. So something like having your application being kind of a host, if you will, and you have a WebAssembly runner that is able to take some WebAssembly application and just run it. So we are there at the moment. There's lots of great runner out there. There's one for Rust that is mostly known, I think, which is Wasmer, and but in Go we do have a package for Wasmer. The thing is that it will require CGO to build your application. So if you don't know when, as soon as you enable CGO, you kind of lose the cross-compiling functionalities, and now you will need to go to each separate, architecture and OS to build your artifact, your binary, if you will. And if you are distributing an open source project in a binary form, that is a bummer, because that is one very, very appealing aspect of Go, which is you can build your application on Linux, and you can build Mac and Windows and BSDs and all sorts of other binaries from your Linux, your main development machine, whatever it is. So I was looking at WA0. I don't know if it's that, it's a WA0, and this is a runtime for WebAssembly entirely written in Go. So there's no dependencies. So there's no dependencies on CGO from what I understood. So, and it's very simple. The idea of those runners is that you have some kind of WebAssembly binary that you build from, almost all languages these days are capable of targeting WebAssembly as a potential target. I was looking at that, and I think even PHP as an example for there's a way to take a PHP, I don't know, a project file. I haven't done PHP since like 1998, but there's a way to target WebAssembly apparently in PHP, and there's one for JavaScript, even for Ruby. So it's not just Rust and Zig and Go and things like that, and C and C++ that can target WebAssembly, although arguably I don't know what is the what kind of tricky things you need to do in those dynamic language to be able to to basically compile your dynamic language to a binary format like WebAssembly. I don't know, but it seems to be possible. So those runner, like I was saying, are there to take those binary and run them directly. So you do that by exposing some function from your WebAssembly program, if you will, and from there, the host can instantiate a runtime and now load this WebAssembly binary directly and call the functions that are exposed, if you will. So if we go back to this idea of trying to have a pipeline or a kind of a dynamic way to inject new functionalities without recompiling anything. So let's imagine we would have a very, very simple Go application. So let's say it's monitoring a directory. Let's call that plugins, whatever extension, and it could basically try to detect if there is any new files that are inserted or created in that directory, and if it's the case, then it could update its own list of available WebAssembly binary that it can instantiate. So you could basically, depending on the use case, you could have file names being very explicit about what this WebAssembly binary could do. For example, if we return to my example of an ETL, for example, and you are receiving lots of files, and let's say that the basic application that you built is capable only to read tab delimited file or CSV, for example, then you could have a directory called plugin or extension, whatever, and have the name of the extension that you want to handle from this WebAssembly binary. For example, you could have an XSL.wasm file, which would be apparently capable of handling the input file being an Excel file, for example. And now you could build this piece of the pipeline in another language. Maybe maybe in Rust there's a way to process Excel file, or whatever the example is. But the point is that now your application can receive new functionalities very easily just by dropping a file name that, as some kind of convention, your application can now dispatch some work to this WebAssembly binary directly, and it's done. It can be done because all the WebAssembly files would need to expose one function name, for example. So if you ensure that all the binaries, all the WebAssemblies will have a function called, I don't know, XYZ, for example, whatever the name, then your host can, take the file input, check the file extension, see, oh yeah, okay, this is an Excel file. I cannot do that myself, but I will try to see if there is something in the extension or the plugins list that I do have that can satisfy this file type. And now it's it is outsourcing all the processing to the WebAssembly binary. So that is pretty interesting. Now there's a couple of very challenging or not very easy things that can happen with this. First of all, the benefits are there. I mean, it seems to be a good way to encapsulate some functionalities that might not be possible to write on the host, or it's not desirable because the host goal is to just be extremely simple. Maybe in the company there is multiple teams, and not everyone works on the same language and whatnot. So at least there's some kind of way to have everything under one final destination, which is WebAssembly. The issue though is, well, I mean the main issue is passing data back and forth from your host application to your WebAssembly function. So due to the fact that not all programming language are the same and are treating pointers and things like that the same, passing struct, for example, or strings or anything is difficult. Passing integer and in 32 in 64, for example, and boolean are kind of fine. You don't have to do things that are kind of dirty to handle those. So my idea would be to have some external way to communicate instead of passing data from a host to the WebAssembly binary using its function parameters. I would just pass some kind of int32 indicator or an int, a unique int to this function that says, you know what, your data is at a certain location, and this is the key that you will need to grab your data. And this data could be, I don't know, it could be a Redis cache, it could be anything that you can think of that would exchange a unique int or multiple unique int, depending on what you want. But so the WebAssembly binary, when its expose function is called, it could receive one or multiple ints and exchange that for the data that it needs. So for if we continue with our example, we would need either the bytes of the receiving file or the file name itself, where it is, and maybe multiple other data that needs to be passed to this process, so it can complete its job. I don't know, but the point is, we would receive one or multiple ints, and now we could exchange that and receive the data, and we could use the return type as well, using an int to indicate, well, this is did it pass? If we return something like a 0, it failed, for example, and if we return a valid int, then this is this is where the results are. So this is the key that you will need to grab the result. So I don't know if it's good or bad. This is what I have what I have in my head at the moment, because I am thinking of using that in static backend. So static backend is a backend, and there's a way for developers to create server-side function. At this moment, I do have a JavaScript custom runtime that enables developers to write function in JavaScript. The issue with that is it's a sandbox. You cannot bring external library. It's not a Node.js. It's not a V8. You cannot do imports and whatnot. It's just JavaScript as a dynamic language. You can do if, you can do for, you can do lots of the basic primitive of the language, but it's not like running Node and things like that. So I was thinking, if I were to support functions in WebAssembly, then it means that the developers could use whatever language they want and whatever library they want. They would just be building a WebAssembly binary and drop that as the function bytes that needs to be executed, and that's it, as long as they expose a function. So this is very similar to the ETL process that we just discussed. But yes, again, the problem is in the exchange of the data, because if you are to pass some custom struct and whatnot, I'm not even sure if it's possible or not. But I mean, there has to be a lots of memory management involved and things like that. I don't know. It seems to be not worth it. Not worth it in terms of times to handle that versus just, you know what, int are just working as is. So let's use a kind of a workaround for that. Maybe I missed something. It's also very possible, but the point is, at this moment, this solution seems to be very attractive. I would say, because I mean, yes, the fact that there's no limitation on the external languages, the external programming language is very nice. I mean, I could see a lot of projects using that from now on. Imagine you have a runtime. Imagine a game, for example. You could have a game, and instead of just exposing Lua as an option, you could say, well, you can write your mod in WebAssembly. I mean, WebAssembly seems to be a good option. I think it's growing very fast, and now that almost everyone is able to target it, and that we do have what I would call very decent runner at this point. So it's not just the browser anymore, and we will have to think a little bit about that, as it seems to have a lot of potential for at least a very good plugin system in that case. And there's multiple other use cases for WebAssembly for sure. So but yes, I just wanted to talk a little bit about that. Food for thought, I guess. And thanks again for listening. Bye.